All right, we've got a lot to cover here, Sam.
Yeah, well, I was warned that I'd have to follow Kelsey Hightower, and I said, that's impossible. Nobody can follow Kelsey Hightower, so we're going to have to take this in our own direction.
So both Sam and I love to talk, so we're going to have to cut each other off if we go on too long.
Oh,
so
no.
if you disagree with something I say, just jump in and say wrong.
I think I might just say kafefe. Has anybody had enough kafefe today?
So Sam and I, as Manish said, Sam is VP Product Management at Google for Google Cloud, Compute and Developer Services. Before that, he was the CEO of the Cloud Foundry Foundation, so he's got some open source practitioning experience and some governing experience. He was at Apogee before that, which was an API gateway platform that Google acquired, and that's how I know him. We used to see each other at board meetings at Apogee.
Indeed.
And back to something Joshua said, we don't like each other, but we respect each other. And
when you see the questions, you'll realize that there's a lot of respect, but not a lot of love.
We're just kidding. We like each other. And way back, he was at Microsoft. He was the leader of worldwide open source and Linux strategy.
And that was in the 2000s when it was really unpopular to be saying Linux was good for Microsoft and that open source was good for Microsoft and that Microsoft could be good for Linux and open source. Now it seems kind of obvious the company has shifted, but in 2006, let me tell you, that was not an easy story to tell. But I believed it, so I'm a believer.
So I've got some serious issues with you, Sam, and with Amazon and Azure. I've said before, and I've blogged about this, that cloud platforms are making the job of an infrastructure software investor tough, because Amazon, for example, just takes open source projects and offers them as a service. They don't really give back to the open source project itself. They don't give back to the commercial entity behind the open source. And that's great for the consumer in the short term because it's commoditizing computing. It's making things cheaper for the consumer. But this can't be sustainable if the open source projects and the companies behind it don't make enough money. Mm-hmm. So is that correct? Do you agree? And is Google doing the same thing or something different?
Yeah, so start with, we're not doing the same thing. It's a losing long-run strategy for a couple of reasons to try to dissociate revenue and sustainability from open source communities. You can never effectively compete with the community once they put their attention on a thing. So if you were to try to harvest these great inventions and just kind of trap them in your own data centers for yourself and not contribute back, you actually have an immediate legacy problem, right? You're just running an old version of software that now it's up to you to patch. So it makes no sense to stamp your feet into the ground, right? You're basically stapling yourself to the floor.
Sam, your mic's not quite working right.
All right.
Give me this.
Effectively, you don't want to, oh yeah, quite a different gain. So I'll just restate, it's a losing long-term strategy to cut yourself off from an open source community, and it's a losing long-run strategy to impact their sustainability. You don't want to ship into your own production, lock in your own data center, something that becomes instant legacy, because the community is constantly moving forward. Can anybody here actually count the number of improvements in Redis in the last 3 years? Like, anybody? Yeah, nobody's brave enough to offer an answer. Maybe we can ask Salvatore, how many improvements? Right, it's spectacular. So if you had locked yourself away with Redis 3 years ago, you'd come out and you'd feel like Rumpelstiltskin. Like, I've totally lost track of where all this has gone. The second big component, though, is that because the future is moving very rapidly and you want to be able to line yourself up with the community, you have to believe in the power of long-run open economics. Even at the national level, when you look at GDP, more open economies grow GDP faster. It's measurable, there are countless studies on it, and when you start to wind that back to clouds, each cloud has an opportunity to be an ecosystem. This is why I care about governing. Effectively, each cloud is its own state. So if you take a look at what we've done with Mongo Labs, Mongo runs on GCP, if you look at what we've done recently with an announcement with Elastic, probably a great counterexample where I think everybody knows the story of what happened with Elastic and AWS. We're partnering explicitly with Elastic to run Elastic on GCP so that as you adopt that software, as you want enterprise support, as you want to run it at scale, it's going to benefit the ISV that is nurturing the open source community, balancing their need to give everything away while making sure that their core business is sustainable and it can start to make more sense for VC, right, for any form of capital that's going to support those companies.
Well, what about the behavior of platforms, though, like Microsoft, for example? When they decided they wanted to be an antivirus or word processing or spreadsheets, they just went ahead and did it and destroyed the businesses of their really important ecosystem partners at that time. So, so being around the gravitational forces of these platforms, how do you make sure that you're not going to get eaten by the platform? And where do you have to be so that you're close enough but not too close?
Yeah, platforms are the sort of the most powerful form of new business models. You can read about it in Platform Revolution, a book from MIT's Initiative on the Digital Economy, published in early February last year. Strongly recommend it. There's a platform governance process where there's always a little bit of attention to build more into the platform. So it comes back to the key is communicating, making clear where are we going, being transparent, being able to show what is the user benefit for being able to add a core feature. What we're trying to do in Google is our focus is to be the open cloud. So making sure that we have a range of offerings. Obviously we have things like Data Store, which is a NoSQL database. We've launched Spanner recently. We might talk about some of this later. That it's a world of choices. We expect that developers choose the technologies they like the best and they want to run them wherever they are. There's no intent that we think that our perspective on how data should be stored, how apps should be written, is the most important, let alone the only one. So being an open cloud means opening to a world of ideas, making sure that we're making people right regardless of what they want to bring to the table.
I don't know, it sounds like a lot of corporate mumbo jumbo, Sam.
I believe it. I've been putting my body in the way of it for, for whatever, 15 years.
Let me ask you something else. What is Google's database strategy? On one end, you have something like Firebase, which is low end and easy and accessible, super cute. And on the other end, you have Spanner, which is a database beamed in from the future with atomic clocks and all sorts of things, but it only runs on GCP. And in the middle, you have Cloud Big Table, Cloud SQL, which is mainly Postgres right now. Are there plans for in-memory databases? Microsoft released a graph database. Graph databases seem to be a popular topic now. Is Google going to release a graph database?
Yeah, a lot of my job at Google as VP of Product Management in GCP is to create two forms of openness. One is to open up what we've been using inside Google to power our business for a long time. And let me tell you, out of a company of 66,000 people with 40,000 engineers, you can imagine there are a lot of points of view internally, right? So it's a very kind culture, which means that we'll have a lot of teams doing similar things, following their own intent. One thing that we've done, that we've publicized some years ago is the Pragle, which is, we published the paper for that. It's the basis of Apache Giraffe, much like Big Table, and the original papers were kind of the kickoff of Hadoop and HDFS. We don't have any plans around it. I wouldn't be surprised if there's a team inside the company that's like, hey, we've got this great thing that we want to open. Spanner is a really good example of that. So we call the public offering Cloud Spanner. We've been using Spanner for years internally, right? It's how Gmail scales, it's how search scales. It's something that allows our developers, right? We've got about 30,000 of those 40,000 developers at our company are working on huge lines of business. We have 8 different lines of business that have 1 billion users each. If we were to pollute all of those application developers, the Gmail developers, the YouTube developers, having to know how to run world-spanning compute and infrastructure, that would be a huge waste of their time and their brain. So we've got 10,000 engineers who've been working for the last decade or more on supporting all of those teams. Spanner came from an internal product to opening up to be an external product that now anybody can use. There's a productization process we have to follow to enable that, but we're going to continue to offer our opinions out. The other half of my job is being open to the world, right? Bringing external ideas into GCP and making sure that they're sustainable. So our point of view on database is pretty simple. There's lots of them. There's no right answer. They all are going to exercise compute, networking, and storage, which is good for our business. Most importantly, once you have this inexhaustible supply of data, it's our job to make sure that it's really easy to do data engineering on Google, because ultimately, we think a lot of the workloads are going to move to machine learning. So a lot of our focus has been on making sure that you've got very easy to access machine learning technology. We've contributed one of the most popular open source projects in the world for that, TensorFlow. If you haven't seen TensorFlow, it's basically the de facto standard for machine learning models. #1 machine learning repository on GitHub. We've coupled that to the Tensor processing unit. We just recently announced a couple of weeks ago at I/O that we've built out boards that have about 180 teraflops of compute per board, specifically for running TensorFlow-based operations. So moving to ML requires an enormous supply of data. So you should be able to use whatever data stores you want, link them up, normalize them, and then make that available for ML training. We think that's a critical area to focus on. And we eat our own dog food, right? We have about 4,000 TensorFlow machine learning models running inside Google today, powering our most popular consumer applications.
Well, take Spanner though. If you can't use Spanner on anything other than Google Cloud Platform. So isn't Google Cloud Platform then pursuing the Microsoft platform strategy?
That's a really fair criticism. I think there's a couple challenges with open sourcing Spanner, which is something that we've been asked a number of times, right? So Spanner stands for a particular set of ideas about no ops, sort of replicability, automation, and if we offered that outside of our data centers, you would immediately lose the promise. The Spanner is built on a few key things that make Google very different. First, we own the fiber that connects our world. So about 25 to 40% of world internet traffic is routed through Google's network at any given time. It's a very low latency network as well. So Eric Brewer, VP of Engineering, who I have the pleasure to be his product manager, the creator of the CAP theorem, was the person who was able to use Google's infrastructure to break the CAP theorem. And if you listen to him explain why this is, there's kind of three key components. One, the underlying network is so fault tolerant, it's so hard to partition. We can give you both consistency and availability in Spanner. We can do zone to zone, multi-region, and global. Second thing is we know exactly what time it is, right? We don't talk about this a lot, but we have atomic clocks in all of our data centers. That is accessed through a unique API called the TrueTime API, which any of our VMs can interact with. So we can have less than a 200 microsecond drift in our clocks as we run Spanner globally. And then the third thing is openness. So implementing the SQL 2011 standard to be able to get data out of Spanner hopefully puts us back in the realm of being able to be consistent with our open cloud principles, which includes open access, right? No barriers to entry, no barriers to exit. You should be able to put your data in and get it back out. You should stay if it's producing value for you, if the system works really well. Sorry for my long answers.
Okay, so I'm gonna switch topics a bit. There's a study out there called Big RAM Eats Big Data, if you want to Google it. And they've been asking, since 2006, a bunch of practitioners the question, what is the largest data set you have been working with? And they've asked this every year. And some surprising stats from that are that 90% of the respondents, their biggest data set that they had used was less than 8 terabytes in 2016. It was much smaller 10 years ago. Only 5% were in the petabyte range. And the data sets have been growing at 20% per year, the size of the data sets. DRAM, on the other hand, the amount of DRAM available in a commodity server has been growing at 50 or 60%, depending on how you do the math. And now, in an Amazon X1 instance, there's 2 terabytes of DRAM available. And I've argued that eventually all operational databases will be DRAM databases. And this is all before the impact of NVRAM. This is just regular DRAM. The operational databases will be DRAM databases. It seems like all databases eventually should be DRAM databases.
Well, it seems like you want to not care about what it's stored in as long as it's meeting your performance requirements. One of the things that many people may not know is that there's a global shortage of DDR3 and DDR4 at the scale that we operate clouds at. So when you can make certain claims about maybe converged infrastructure or servers that you might be running on your own data center, you're going to manage that performance in a particular way. When you get up to planetary scale databases and planetary scale infrastructure, some of the math starts to change partly because of how we use the network. So we can help you not care whether you're running on a diskless architecture, whether you're running on SSD, whether you're running on all RAM. One of the things that you have to start worrying about is locality of reference to what's accessing that RAM. So are you trying to use GPU-heavy workloads? Are you running TPU-heavy workloads? Are you able to have affinity between the processor and the application logic that you're trying to execute, and where are your supplies of DRAM? So what we're starting to see at our scale is we start to think about a computer as being roughly 100 racks, right? It's no longer a single node because our top of rack and our ring networking is so speedy. We can get you into a place where you actually don't care which computer, which machine, which capability is running on. So DRAM is interesting, but
well, I was asking a more simpler question,
Sure.
which is the design center of Redis, for example,
Sure.
is DRAM.
Sure.
And that seems like the right place to be for the future, rather than all these fancy things people are doing with disks and disk-based transactions.
Yeah, well, it does come down to cost optimization at scale, right? Not all storage is created at the same cost.
All right, let's talk about AGPL. Now,
That's a fun topic.
Google's banned. Now, the Redis modules are AGPL. There has to be some way for the commercial entity behind an open source project to make money, and that's one way. And then there's some closed source features in Redis Enterprise. But Google's banned AGPL. MongoDB is AGPL. So is that a mistake or pure genius?
It's a case-by-case issue. It's something that you have to look at. What does it mean for the packager? What are the requirements? What does it mean to the consumer software? So I think ban is probably a strong word, right? We're very thoughtful about how intellectual property flows between the users of the software, the virtual machines they run on, the cloud infrastructure beneath it. As you know, Mongo runs MongoDB directly on GCP as a first-class citizen. So these things are solvable. Often companies that are running AGPL have a dual licensing strategy, right? So AGPL is also a mode to make sure that you can be protected and make money, because when it's hosted, if you don't want to give away those rights, then you pay for them differentially. So it's not that different from the world of the dual licensing GPL model that we had pre-cloud. So I think there's a very clear strategy for monetization for open source companies that is still working. Obviously, AGPL raises the complexity of actually figuring out how to do business deals, but it's not impossible.
Okay. Well, we could talk longer about that, but we have to go on to the next question.
That rabbit hole is very deep.
So let's talk about one particular company, Docker.
Sure.
Now, here's a company
Just down the street.
Yeah, it's got huge hype, strong usage, but
New
barely,
CEO.
A new CEO.
Steve Singh just came on board.
Had barely any revenue. So what did they do wrong? And do you see a world where virtual machines give way to containers only, and containers running on bare metal?
I think the right business model can look wrong for a long time. And what I've learned in my 15 years as a strategist is I'm not really smart enough to predict the future. Often I can't quite even predict the past. Predicting the past is a good start. That's actually quite difficult. Some key changes may show up that make that business model brilliant, and everybody says, oh my gosh, there it went. Actually met Solomon Hykes back in 2009 when he was still running a tiny company called .cloud, and he was moving over from Paris and asking himself, could he land in San Francisco and start to chase the Silicon Valley revolution and that dream. What they've done dramatically well is to create abundance where we used to have scarcity. Right? The abundance of containers, the free-flowing use of containers on every cloud, the basics of that abundance also caused us to offer Kubernetes as an open source project. Somebody over there is wearing my favorite shirt, Run Kubernetes, taken off of one of my favorite 80s bands, Run DMC, so nice logo, sir. Kubernetes only has a problem to solve because of the abundance of containers. So Docker's done developer experience and container ubiquity brilliantly. Now, in creating that supply, I suspect that there will be a durable business model. The fact that they haven't found it yet doesn't mean that they won't have one. And this is kind of part of the interplay between venture capital, why these companies get built in Silicon Valley, because we can continue to speculate and say, What we don't know now, but to quote Ronald Reagan, there has to be a pony in there somewhere.
Okay, so last question. You were involved in a couple of governance bodies, like the Cloud Foundry Foundation. It feels like whenever an open source project is governed by a foundation of that kind, and there isn't a strong commercial entity behind it, it gets mired in bureaucracy and stagnates.
What would be an example of that?
Well, there are a lot of open source projects that don't have commercial entities behind them and aren't and therefore haven't been monetized, and therefore there isn't as much R&D being put behind them. So isn't it a better model to have a strong commercial entity behind every open source project?
I think there's two real different sort of flows within open source. You can kind of call it, flow 1 and flow 2. Flow 1 is a community has come together and built this stuff from scratch, and no commercial interests were involved in the first place. And a lot of what we think of as open source from the 90s and even the 2000s kind of comes from this whole tradition. So when you create a foundation for a community like that, there's already trust, there's already really a lot of good behavior. You're looking for a way to say, you're all doing a good job, we'd like to give you some money, we'd like to be able to let you throw a conference, right? It's usually a different form of governance. Then you start to have community conversations, say, what's our code of conduct, right? That's a tricky area. Flow 2 is sort of these newer, maybe 2010s era foundations, which are built as trade associations. Cloud Foundry Foundation has Pivotal, IBM, EMC, VMware, SAP, right? Giant companies coming together. You have to have a system that bootstraps trust. So in the case of the from scratch collaboration around a net new open source project, it's really important to have a foundation so that multiple companies can cluster around it, share something into the commons, make sure there's not going to be a tragedy and won't get robbed, and that the whole thing is going to be sustainable. So I think those are the two ends of the stick. If you don't have commercial success around an open source project, it is at high risk of abandonment. I used to work for the Cloud Foundry Foundation, which is part of the Linux Foundation. There was a point in time, I think in 2015, where NTP, right, everybody knows Network Time Protocol, right? NTP was languishing. It had one maintainer. This is arguably one of the most important protocols running on the web. The lead maintainer was like, it'd be nice if I could get like a few $1,000s a year to run the server, right? So here's father time of the internet, and everybody has just kind of passed it by. So we do have to put our attention on how do we contribute to people who are supporting critical infrastructure, because not everybody's running a VC-backed startup, not everybody's a consultant. Some people are still running really important technologies, really important projects that we all depend on, and nobody's taking care of them. So that's where an organization like the Linux Foundation can do a really good job attracting capital and then figuring out how do you sustain the community by giving community grants for those kinds of projects.
All right, that's all the time we have. Thank you, Sam.
All right. Thank you, Salil. Thank you, everybody.